Children, welcome to my channel Cerebral Physics, Lecture 3, topic Force and Motion. Today, subtopic I am discussing with you, that is graphical representation of motion. Look at my blackboard, whiteboard. That first graph 1, the body at rest. Body at rest. Now this is the time, this is the displacement parallel. Here, if displacement parallel to time, that means displacement constant. Displacement constant. Displacement constant. Graph 2. If time and displacement, now you see this is slope tan theta, this is tan theta, that is slope, it is constant. You see slope is constant. So if displacement time graph slope is constant, we say body moving with uniform velocity. It tells uniform velocity. Uniform velocity. Again, you can represent uniform velocity like this. This is time, this is velocity parallel. It is also uniform velocity. But if graph is like this, t and x like this, we see slope variable at the point P. This is the slope theta 1, at the point P, slope theta 2. Slope variable means non-uniform motion. Non-uniform motion. So first case displacement 0, displacement constant. Second case uniform velocity, and that case uniform velocity, and it is non-uniform velocity. That means velocity not constant. Sometimes it is moving with 5, then 7, then 8 meter per second like this. So all this graph I have discussed for body at rest, that is uniform motion, non-uniform motion. Now if we represent the graph for accelerated motion, how can we represent? Let us see. Accelerated motion, what we will get, let us see. Suppose V and T, in that case slope constant, that is tan theta, that means uniform acceleration. It represents uniform acceleration. Uniform acceleration. Slope tan theta, that is uniform acceleration. It is also body moving with acceleration like this, but slope changes. We see slope tan theta 1, tan theta 2, tan theta 3. Slope variable, it is non-uniform acceleration. This graph represents non-uniform acceleration. Non-uniform acceleration. It is graph 3. If slope constant, that we should say that it is uniform acceleration. If slope not constant like this, so non-uniform acceleration. Now you tell me, suppose two bodies A and B moving. Now first case slope tan theta 1, and for B slope tan theta 2. Now write down slope of VT graph. Slope of VT graph will give you acceleration. So we should say slope of B greater than slope of A So acceleration of B greater than acceleration of A. So from VT graph, from slope, we can say the acceleration of the body. Now in VT graph, if you measure the area, suppose you are measuring area, it is area plus 100 minus 100, it is plus v, downward minus v. You know velocity is a vector quantity, positive velocity upward, negative velocity downward, and time suppose 0 to 2 second, it is 8 second. Suppose it is 1, it is 5, then it is suppose 1.5. So it is clear that if you calculate area, positive area A, positive area A plus, and this is negative area A2, this is negative area. So net area will give you the displacement, net area displacement. That means this area minus this area, displacement will get, but if you don't consider the sign, only if you calculate A1 plus A2, it will give you distance. Again I am telling, from VT graph, if you take positive area minus negative area, net area will give you displacement. If area equal to 0, then it will be net displacement 0. But if consider only area, then we should say it is distance. So again I am repeating, from the board you see VT graph has been drawn. We have taken two particles A and B, slope of A tan theta 1, slope of B tan theta 2. Now slope of B is more than slope of A, that means acceleration of B is greater than acceleration of A. Now you see here what information you obtain from this graph. You are getting information that VT graph is given but slope is variable. That means this body moving with acceleration but not with uniform acceleration, it is non-uniform acceleration. It is non-uniform acceleration. Non-uniform acceleration. Non-uniform होगा. In this case, we have drawn a VT graph. Now I am telling you that VT graph we have considered two area, up area and down area. Up area positive or V positive T area. The positive in this and positive area minus negative area will give the net area. Net area will give you the net area will give you A1 plus minus A2, that is a displacement. Here this is displacement. Now this is the situation. So what we have discussed today with you, that uniform motion, accelerated motion, uniform, non-uniform. Then we have distance time graph we have obtained. Now I am discussing with you in which case one-dimensional motion is not possible. If you see any graph where you remember one rule, at a particular time, a body cannot occupy two different positions. That means at a particular time you cannot stay in Bombay and Delhi simultaneously. That means at a particular point, for a moving body cannot occupy two different positions. A moving particle cannot have two different velocities. That means at a certain time a body cannot occupy two different velocities. Number 3, time, distance and speed cannot be negative, cannot be negative. That means, suppose this graph is not possible. I am drawing one graph. Time, and that is displacement. If you take a parallel line, we see this parallel line cutting the graph at two positions. We are getting two displacement. One is x1, other is x2. So this is not one dimensional motion. This is not one dimensional. This is not one dimensional motion. Clear? This is not one dimensional motion. In this case, what is observed that at the same time we are getting two different positions for the moving particle. That is not possible. So this type of graph is not possible for one dimension. So if we observe any graph where a particular time body taking two different positions, this graph is not possible. If we observe that two different velocities is taken, not possible, and distance, speed and time cannot be negative. So this type of graph is not possible. As for example, at time t, maximum velocity is 10, and in that case 9 am, particle velocity 10, and it is 8, 9, same particle, after moving it cannot, displacement cannot, distance cannot be negative. So velocity cannot, two different position, two velocities are, then it cannot be 0 at the same time 10. Again I am telling you this very clearly. So again you remember, at a particular time a body cannot occupy two different positions. A moving body cannot have two different velocities at a time, and this graph is not possible. Suppose time is positive, time is negative, this type of graph is not possible. In that case, time is negative, it's not possible. Time always positive direction, positive sense. Time cannot reverse back. So today what we have discussed in brief, I am telling you, you consider a motion with the help of displacement time, velocity time, information from velocity time, uniform motion, non-uniform motion. Now I am getting a particular graph. You tell me what information you obtain from this graph and what distance the body moving. As for example, it is 10, body attaining maximum velocity 10 meter per second in 3 seconds. The next 4 seconds, it is 3. Next 4 seconds, moving with constant velocity. Then up to 3 to 4, 7 seconds, that means for 4 seconds, velocity constant. 7 to 10 seconds, gradually velocity decreasing to 0. Now in this case, first 3 seconds, uniform acceleration. For 4 seconds, uniform velocity, and next 3 seconds, uniform retardation or negative acceleration. Uniform retardation. First 3 seconds, if this graph, if I ask you, what is the total displacement you calculate? Already I have told you, this is V, this is T. So total area, this is the area of the triangle 1, this is rectangle 2, area of rectangle 2, triangle 1 and triangle 2. So if you consider 3 areas and you add them all, you are getting displacement. Clear? We are getting displacement. First calculate the area 3, 10, that will be 15, half base into altitude, 4 and 10, that is 40, and that is 3 and 10, that is again 15. So total 15 plus 15 area plus 10, so displacement 40 meter. Clear? I hope it is clear for you. So when you do this chapter, you practice equation of motion, already I have discussed with you. Graphically represented motion, already today I have discussed. And next class we must do numericals on the basis of this chapter, graphical motion as well as equation of motion. Thank you all. Again, next video I shall meet you, all of you. I hope you will do better in next future.